Let's continue in section 2.1 excuse me, with the graphing a function by plotting points. And this is something you're familiar with, something you've done in a class previous to this, and we just want to plot some points and notice or observe anything that happens between the three graphs that we have mentioned here. So let's start with the absolute value of x, and I've pre-chosen the x values for you. All we need to do is plug them in and do the arithmetic. So let's look at the absolute value of x, and let's plug in the -2. So it's the absolute value of -2, and remember how the absolute value works. Anything inside the absolute value where it's positive or negative, the answer is always positive. So absolute value of -2 is 2, absolute value of -1 is 1, absolute value of 0 is 0, absolute value of 1 is 1, and absolute value of 2 is 2. So we have these ordered pairs that we can work with and plot the function f of x equal the absolute value of x. So let's go ahead and do that. I've got the point 0, 0. I've got the point 1 goes up to 1. I've got the point 2 goes up to 2. Then -1 goes up to 1, and -2 goes up to 2. So what we see here is sort of a V shape for our graph. Absolute value function is going to have this V shape. And looks a little bit better, like if you're doing it on a graphing calculator or something like that. But we get the idea. It's a V shape. Let's look at the next one. Let's plot some points and then notice observe what's going to happen between the original one and the two we'll plot after it. So very quickly we can put in the -2 and get the absolute value of -2 minus 2. So it'll be 2 minus 2, which is 0. Absolute value of -1 minus 2 will be a -1. Absolute value of 0 minus 2 is -2. Absolute value of 1 minus 2 is -1. Absolute value of 2 minus 2 is equal to 0. You notice how the values repeat themselves. Let's see, plotting those, we have 0, -2, which is down here. Then we have 1 that goes down to -1, and 2 that goes to 0. We have -1 that's down to -1, and -2 that's at 0. Now it's the exact same V shape. I should expect that with any absolute value. With these absolute value functions, it's a V shape. But if we notice, the first one was the absolute value of x, second was the absolute value of x minus 2, and how has the graph transformed from the first to the second? Well, we can see that it went down 2 units when we compare. What do you expect to happen for the next one, which is going to be the absolute value of x plus 4? Well, the -2 went down 2 units, so I would assume the plus 4 is going to go up 4 units. But let's go ahead and plot the points and see how that works. So putting in a -2, absolute value of -2 plus 4 will be 6. Absolute value of -1 plus 4 will be 5. Absolute value of 0 plus 4 is 4. Absolute value of 1 plus 4 is 5. And absolute value of 2 plus 4 is 6. So we see that repetition. Starting here in the middle, 0 goes up to 4. We'll plot that point. +1 goes up to 5. +2 goes up to 6. -1 goes up to 5. -2 goes up to 6. So the exact same V shape we see occurs over here because it's an absolute value function. But notice this one, when I compare it to the original, has been shifted in a direction where it goes up 4. So if you know the basic shape of an absolute value, then really you can just sort of by inspection understand what's going to happen with these two guys. Just take that picture and shift it up or down for that value that is separate from the absolute value. So our observations would be simply the graph shifts up or down. Okay, what else do we have here on this sheet? Some definitions, very important definitions we'll use throughout the semester. Some you should be familiar with. Actually, all of these you should be familiar with. X-intercept. We know that's the point where the graph crosses the x-axis, but here's something new. Another name for the x-intercept is the word zero. We'll use that often. Y-intercept, the point where the graph crosses the y-axis. And remember, that ordered pair where it crosses, for an x-intercept, it's x comma 0. For a y-intercept, it's 0 comma y. An open dot, when we have an open dot on a point, that means the point is excluded, and we use a parenthesis on that type of endpoint when we start working with interval notation. Closed dot means the point is included, and we'll use a bracket on that type of endpoint, again, when we use interval notation. And we know domain and range, we've talked about it a lot, domain set of x, range a set of y, but we'll actually have to find the domain and range of a function, so we'll move left to right along the x-axis, and for the range, we'll move from bottom to the top along the y-axis. So we'll move along those axes to determine the domain and range of a function. So let's take a look at this one. I've given you 3 functions, and we want to determine the domain and range. That looks like it's a dotted line, but actually these are nice solid lines. The screen capture didn't come out very well on that, but these are nice solid lines. So domain, we're going to move left to right along the x-axis. Here is our x-axis to understand or to determine our domain. So it's like taking, it's like taking your finger or something, and you're going to go left to right, noting the starting and the stopping points of where your graph starts and where it stops with respect to the x-axis. So as I move left to right along the x-axis, I notice the point where I hit my graph first is right here. That's where this graph starts. As I go left to right, that's my starting point. It's not very clear on here, but it's actually -3. Now, as I move left to right, I continue to touch that graph. Where do I stop? Well, I'll stop here at this point. So notice my domain starts at -3, stops at 2. -3 has a closed circle, and 2 has an open circle. And if you look back on the previous sheet, we said we're going to represent those with some specific, with a specific notation, a symbol. So using interval notation for the domain, we'll note the starting point of -3, comma, the stopping point of 2. As we go left to right, it starts at -3, stops at 2. But we have to use the proper notation, and since that's a closed circle, we use a bracket. Since that one's an open circle, we use a parenthesis, and that's our notation for domain for this first function. Let's do the same thing over here. Let's work left to right, determining where this function starts on the x-axis and then where it stops. So as I move left to right, I notice my graph starts here. I first encounter my graph here at -3. As I continue to move left to right, notice that graph is available until we get to this point. Now let's put some endpoints. That's actually a closed circle, and this one actually should be a closed circle. So my graph spans on the x-axis the values -3 to 0. So it starts at -3 and stops at 0, and that's on the x-axis. So we have a starting point of -3, a stopping point of 0, and what type of symbol will we use on those endpoints? Since they're both closed circles, we'll use brackets. Open circles get a parenthesis, closed circles get brackets. Last one, let's look at the domain. Now on this graph, I want you to put in some arrows because this parabola just continues to go up in each direction. That's going to affect our domain, so we want to make sure we have that on there. The fact that it has arrows on it, or the fact that I made you put arrows on it, tells us that as I go to the left, this graph continues to infinity. Out here on the left, this graph on the right-hand side just continues to go up and out. Now I kind of showed that exaggerated that a little bit, but that's actually what's happening. This thing just gets wider and wider. The left side gets wider and wider. For this type of function, it's not that obvious. You might want to say the domain goes from 0 to 10, but because they're arrows, the domain is going to actually be all real numbers. Because as I go left to right, since this thing spans left and spans right, the domain is going to be all real numbers. And I can note that as a negative infinity to positive infinity notation. Domain is negative infinity to positive infinity. Always use parentheses on infinities. And that's because there are arrows on the end. There's no stopping points. It just continues to the left and the right. And since this is our x-axis and we're covering it left to right, it's going to be all real numbers. Now let's change our direction and look at the range. The range goes from the bottom to the top. So we want to span this graph starting at the bottom and seeing where we first encounter that graph. Well, right here is where we first encounter, as I go bottom to top, it's where that graph starts, here at -1. As I continue to go up, it continues and stops at this point, but on the y-axis, what's that value? Well, here it's starting at -1, and that value looks to me like 4. So for the range, we look at the y-axis between my green lines, and my starting point is a -1, and my stopping point is a 4. What kind of symbols? Bracket on -1, since it's a closed circle, and parenthesis on 4, since I had an open circle. So it's just like using those endpoints. This is the point -3, -1. Notice I had -3 on the x, -1 on the y. This is the ordered pair 2, 4. Notice I have 2 for the x and 4 on the y. 2 for domain, 4 for range. Let's do the same thing over here. Let's go from bottom to top, noticing where the graph starts and where it stops. So as I go bottom to top, I'm noticing this is the point at which I first encounter my graph as I go bottom to top. As I continue, I notice the stopping point of the graph to be here. So between the green lines are going to be my range. Well, I see a starting point of -5 and a stopping point of -1. Starts at -5, stops at -1, and since there's closed circles on both one, we'll mark that with a bracket. So left to right between the yellow lines is my domain, bottom to top between the green lines is my range. Let's go this last one and figure out the range. Again, we'll start at the bottom and work our way to the top, and as I go from the bottom to the top, I notice this is where it starts. It's the first time going from bottom to the top I encounter the first part of my graph here. Oops, didn't mean to do that. And now I continue to go up, and notice the graph continues to go up. Does the graph ever stop? It doesn't stop at 10. Those arrows tell me it's going out to infinity as I move along the y-axis. So I've got a starting point of -10, but I don't have a distinct stopping point. It actually stops at infinity. So I'll say starting point -10, stopping point infinity. Bracket on the -10 because that point is actually an included point in my parabola. Always use a parenthesis on an infinity. Finally, x and y intercepts. All we have to do is investigate the graph to determine the points at which the graph crosses the x-axis or where it crosses the y-axis. So let me go and pick a different color that I can go in and show those. Let's see, I didn't use blue. All right. X-intercept is where it crosses the x-axis, and there's an x-intercept right there at -2, 0. Any x-intercepts here? No, the graph doesn't go far enough to cross the x-axis, so there's none. Any x-intercepts here? Well, it crosses the x-axis there, crosses the x-axis there. Looks to me like it's at the point 2, 0, and 10, 9, looks like that one's at 8, 0. So x-intercepts where it crosses the x-axis. Now let's pick a different color and do some y-intercepts. Let me go with that blue. Y-intercept is where it crosses the y-axis. So if I look along the y-axis, I can target a y-intercept right there at 2, and it's written 0, 2 as an ordered pair. Y-axis right there is actually where the graph stops, but that's going to actually be our y-intercept, and it's going to be at 0, -1. Now I'm going to assume that this one over here, obviously it has a y-intercept, but since I kind of messed this graph up right here, I'm just going to say it's right there at 10, because the graph continues to go on from there. So y-intercept at 0, 10.